In homework 2, there are a couple of problem types where you're looking to simplify a logic expression using Boolean algebra and the properties for Boolean algebra. All right, so let me give you an example, and this has all the elements in it. It's just a matter of you using these properties and these techniques to come up with the simplification. Now, I admit, it's not super easy to do. It takes some practice. And what we'll learn later in the course is that you can use Carnot maps to help guide you on how to do these simplifications. All right, but I think it's important to work on this and try to do the best you can and see if you can see how these properties work. All right, so we're going to start with this logic expression. F is a product of sums, and we're going to try to reduce that. All right, so to get started, what I want to do is multiply this or expand this by a bar. All right, so if I multiply a bar by this term and this term and this term, this expands. I get these three terms. Okay, and if I do the same thing with b bar, I get these three terms, and I'm trying to put the variables in alphabetical order as I go through that. So I get these three terms. And then if I do it yet again for C bar, make that in blue. B bar was in green. I get this expansion. All right. So you're probably good with that. It's a little tedious to do, but that's the first step. All right, from there, what I do is I start trying to notice terms that can factor out. All right, so maybe I would say, going with a different set of colors here, now that we know about this expansion, let's remove these colors. And what we know is, first of all, a bar ended with a is 0. All right, and then what I'm looking for is a bar, b bar with a b bar. All right, so I notice those combinations because I can combine them. We talked about logical adjacency. That's what we're doing with that step. So I notice this a bar or a ended with b, and you can see where that's going to simplify. All right, so look for any other patterns that you might see with that. So here's another one. I'll put that in this orangey red. All right, so I see an a bar c bar, and I see an a c bar. Only one variable changed, and so that can be factored like so. All right, and then I'm seeing here put that in green, b bar ended with b bar, that's just b bar. All right, next observation is that b bar c bar shows up twice. It doesn't need to show up twice. Okay, and so we have, I copied that down wrong, but we have this showing up here. Whoops. And then finally, C bar ended with C bar is just C bar. All right, so those are the terms that we have so far and how I arrived at that. And we see we've covered everything. All right, so then what I notice is that a bar ORed with a is 1. A bar ORed with a is 1. And so I can write this down as just b bar, c bar, and then I already had a b bar and a c bar. I'll write those again. But one thing to notice here is that this is a case of absorption. All right, so you can look up that absorption property, and you see that b bar ORed with b bar, c bar, the The extra anding didn't, it was all covered by the B bar. So this absorbed into that expression. All right, and so we end up with B bar or C bar. That was covered twice. And so you only need it to cover once. That's another property. And you end up with a simplified expression that comes down to just B bar or C bar. All right, so I'd like you to work on the homework, play around with these properties, see if you can get that as simple as possible. If you turn in an answer and it's not the most simple form, you'll get the answer reported back to you, and you can redo that with the extra credit section for homework 2.